So good morning, good afternoon, good evening. Welcome to the topDNS Best Practice webinar on navigating Web3 domains. There are still people joining the room. The webinar will begin shortly. Please hold the line. Hello and welcome to the topDNS Best Practice webinar. There are still people joining the room. The webinar will begin shortly. Please hold the line. Okay, let's get things started. So once again, good morning, good afternoon, good evening. Welcome to the topDNS Best Practice webinar, Navigating Web3 Domains. My name is Lars Steffen. I'm the head of Digital Infrastructures and Resilience at the ECO Association, also the project manager of the topDNS initiative at ECO. And I'm happy to welcome our speaker for today, which is Paolo Domengetti he's the CTO at Freename, also an ECO member, and it's also the second time that Freename is participating in this webinar series. So welcome, Paolo. Before we dive into substance, I would like to take you through our housekeeping rules. So as always, of course, this webinar is being recorded. The recording will be available after this session. You are muted throughout the webinar, but we would like to have this webinar being as interactive as possible. So of course you can ask questions. So you can use the questions part of the webinar dashboard, or of course you can also raise your virtual hand. We will unmute you, and please state your name and your affiliation before you ask your questions, and then we would like to discuss it with you. And after the webinar, as always, when you participate at Eco webinars, there will be a survey displayed as soon as the room will be closed. It is always helpful for us if you could provide feedback so that we can work on our content and improve the formats and the offers that we are offering to you. Just a brief introduction to the topDNS initiative. So the topDNS initiative was created in 2021, where a group of ECO members gathered and asked the association to be more active on the issue called DNS abuse, at least in the DNS industry. And as you can see, we have a number of supporters that is active on this initiative. And also we have a steering committee of well-known individuals from the industry that is gathering regularly and heading the group in the right direction. What we are doing, so we do a lot of outreach. So we organize on a regular basis workshops, for example, at Nordic Domain Days, but also on day zeros at ICANN events in the past. We do outreach to the European Commission. So with our members, we meet on a regular basis with the European Commission to demonstrate the progress that the industry is making, but also what are the most recent outcomes of the topDNS initiative. If you would like to learn more about the topDNS initiative or would like to participate in this, please go to our website, topdns.eco, or reach out to me via topdns@eco.de. There you will also find the recordings of the previous workshops. So as you've seen, this is the ninth edition in this series, and you will find the recordings on our websites that will cover topics like um, how to mitigate online abuse with free tools, also about standards and frameworks for evidencing abuse online, how to reduce abuse through quality, and a number of other topics that you can find there. You will also find there our reports from previous workshops, or also what is always very useful, a table where we have a list of different types of abuse. If we consider from an industry perspective of if this different types of abuse are DNS abuse, yes or no, and also you find different columns of the different stakeholders and providers along the value chain of the industry where we think you should contact first in terms of mitigating different types of abuse. Where can you meet topDNS next? So on the 29th of April, we will host a DNS abuse workshop at the Nordic Domain Days. This workshop will be on site, but also available remotely. And of course, as soon as we will have the login data available, we will share it with our community. The next webinar that I would highlight is also taking place on the 15th of May about the global domain report that is regularly published by InternetX and SEDO. You will find the date and also the registration for this webinar shortly on our website. It's not available yet, but you can already register for the 18th of June for the next ICANN readout webinar, because every ICANN meeting will be covered by ECHO with a summary in this readout formats, where we provide a 90-minute overview of what has happened at the most recent ICANN meeting. You can find all those events and registration opportunities on our website, like international.eco.de/events, or just subscribe to our newsletter and you will have all the updates and most recent events and webinars in your mailbox. And with this, I would like to hand over to our speaker today. I'm very glad that we have Paolo with us, who will take us through the world of Web3 domain names. And it's not only about introducing us to the world of Web3 domain names. I think it's also it's also a great opportunity to learn more about this, because he will also touch upon the challenges that you might have with Web3 domain names. And with this, I would like to hand it over to you. And as I already mentioned before, if you have any questions, please feel free to share them within the questions pod or to raise your hand. And now, Paolo, the floor is yours.
Thank you very much, Lars. It's a privilege to be part of this webinar and presenting. So good afternoon, everybody. At least for me, it's afternoon. Good morning, good evening to everybody. I am Paolo Domenichetti, the CTO of Freename. I will now present what we do, actually, or at least introduce what we do, but most of all, introduce an interesting topic, which is Web3 namespaces. And for that, I will start the presentation right now. So, for the topDNS initiative, this webinar is titled Navigating Web3 Domains. When I start talking about Web3 domains or Web3 namespaces to a public that is not maybe completely aware or is not really inside the Web3 world, they ask me, but what are you talking about? What do you mean by domains? So we have namespaces that are defined on blockchains. Blockchains are decentralized digital ledgers that are immutable, transparent, and the information stored inside it is validated through a consensus made by a network of agents that run a validation process to assess, validate, and confirm the very same information stored inside it. Of course, blockchain are not only used for cryptos. Many of you may know blockchain through cryptos or any kind of crypto asset, but we can have many kind of assets. Actually, we have domains, which in this case are not different from classical domains, those that are very well defined and formalized by ICANN and IANA. And they are represented through NFTs, so non-fungible tokens, which are special tokens residing on blockchains. Unlike classical domains, however, the ownership is direct, meaning that a user, a person, may own directly this NFT representing a domain. And these domains are stored in what we call wallets. Wallets are kind of buckets, repositories where we can store and manage blockchain assets. The fact that that ownership is direct, and the fact that although the blockchain being transparent but anonymous, this creates whole a set of assets that is censorship resistant, which is in a way a good thing, but can create many challenges, as you may think. On top of that, we have different namespaces with different sets of domains. And each namespace, as of today, for different chains, creates its own protocol. And for example, we have Freename, which is a Web3 namespace, although we are also an ICANN accredited registrar. There is the Ethereum namespace, Handshake, Unstoppable. They are all actors that move in the world of Web3 domains. Why namespaces are foundational to Web3? First of all, domains on the Web3 on blockchains are not only strings, are not only crypto assets or assets represented by NFTs, but they may be used, they have a usage. And for instance, we may use Web3 domains to map to or point to wallets address, any other identity or address on blockchains, apps, and any kind of assets that can be referenced through addresses on a blockchain. They are used also to build what we call decentralized websites. They can point to smart contracts that are a sort of programs that may be executed on a blockchain, and they may also be used as for payments. And we will see a practical example in 5 minutes. We already understand that as with the classical namespace, the ICANN one, we need consistency to provide trust and to provide a way to use consistently domains, meaning that, for example, a domain should point to some kind of address, as, for example, a domain through a classical domain through A records may point to an IP address, or maybe can redirect through a CNAME record. However, since we have many namespaces, fragmentation and lack of standards are still a challenge, and most of all for security. And that's what I want to bring to the table with this webinar. I want to show 3 categories of challenges that are not different from the challenge that we may have in the classical namespace, but that have yet to be, first of all, completely assessed and then solved. So first, a panorama. I now cite, let's say, 3 very well-known namespaces. We have the Ethereum namespace, which is based on the Ethereum blockchain, one of the first blockchain that have been publicly deployed. with more than 3 million domains defined on it. We have unstoppable domains, which is actually, it's not a secret, a competitor of Freename. They have also millions of domains, and they provide also top-level domains. We have then Freename, which is maybe the most free and usable namespace because Freename provides a multi-chain approach. You may define your domains on different chains, and you may also define top-level domains. Maybe you are asking yourself, top-level domains, what does this mean? Do we have registry and so on? No, simply since domains represented through NFTs are strings, we have the ability not only to issue SLDs, but we can also issue TLDs, and other people can issue SLDs under a given extension, a given top-level domain. I want now to show a practical example of how we may use Web3 domains. Since I said in the introduction that, of course, blockchains implements cryptocurrency, for example, we may use domain to perform what we call the pay-to-domain, meaning that we may use domains instead of wallet address to send crypto to my friend or to another person. I will now show, for example, that by using MetaMask, which is a wallet manager, we may send coin simply by putting a domain instead of a wallet address. So we may take dude, for example, dot Satoshi, and you may see that there is something particular here. You see a top-level domain that is not a GTLD, of course, not even a country code top-level domain. This is a completely Web3 top-level domain. And we may see that this wallet manager actually resolves this domain to a given wallet address. This information is actually provided by the Freename infrastructure, but I will talk later about how we do this. Once we selected the domain representing or pointing to a wallet address, I may then choose to send, for example, 76 POL. Okay, I don't have them, but whatever quantity of a cryptocurrency on a given blockchain, and I may confirm the transaction and send cryptocurrencies to my friend or to my partner. This is a fast example to show how usability can be achieved through Web3 domains. And I wanted to use MetaMask, which is a wallet manager, actually because it's one of the most used by the crypto community to perform payments and send crypto to other people.
Paolo, if I may just shortly interrupt you.
Yeah.
If you have just shown something next to your slides, it wasn't visible on the screen.
Sorry. You don't see the MetaMask extension?
No, we just see your slides currently.
This is the way, so I will change the way I share. I just go with the entire screen, so that I just repeat the example. Apologies. You may see now, for example, what I have opened is what I said is MetaMask, the wallet manager.
Now we can see. Thank you.
You can see now. Okay. And here, when you want to send cryptocurrency to another person, normally you would copy paste a wallet address provided by your friend, by the target of the transaction, but you may also use actually a Web3 domain that is resolved to a wallet address. We may select it, we may choose a quantity of cryptocurrency to send, and by confirming, we can send the money or the cryptocurrency to our friend. As I said, this is one of the most speaking example of usability through MetaMask, which is a wallet manager, and we just use the Web3 domain that maps to a wallet address actually to send funds to another wallet address. So this gives me the opportunity to alert. We see that we may use Web3 domains to perform payments, which is something very important that should be ensured, validated, and secure. And actually, Web3 namespaces face the same challenge that we may have in what we call the Web2 namespace or the ICANN namespace. This means that namespaces in the Web3 world have to be predictable. They have to implement an intentional behavior that gives us what we call secure outcomes. For instance, if I define a domain pointing to a wallet address, this should be granted. There should be a system in place that grants that this information is not changed by hackers, by malicious agents, and so on. But we also have other problems. We have many namespaces, and one of them is, of course, what we call namespace collision. It means that on the Freename namespace, we may define a domain, but maybe somewhere in another namespace, somebody else may define the very same domain. And this implies a problem of collision. We also face domain abuse. We also face domain spoofing, as it happened in the classical domain space. And all this implies that we have to put in place and implement an infrastructure that avoids collision and then prevents abuse, as we do in the classical namespace. So the panorama as of today is very fragmented. We have more than 10,000 top-level domains defined on Web3 namespaces, and more than 100,000 SLDs that overlap or collide, either inside some namespaces or even in between different namespaces. Why this happens? Why? Because there is no global authority. We do not have a centralized authority like ICANN that ensures uniqueness and control of a domain. And since different namespaces use different protocols, it is very easy with a lack of rules to create the same domain on different blockchains through different namespaces. This brings on the table many problems. We have trademark problems. For example, we may create user confusion. Send me money on this domain, please. Yes, but which namespace did you use, on which chain, and so on. Phishing and other case of abuses. This means that we have to find a way to structure, to formalize a protocol that yields secure results. I provide here a list of colliding top-level domains, meaning that these are top-level domains that have a lot of domains under them that collide in between namespaces. So let's focus first on collision. It's still an important issue. Why? Because we have different namespaces. We had a recent example, for example, with the internal top-level domain that had some overlaps through different private namespaces, but we also have pure Web3 collision. For example, we have ICANN Web3 collision. So there are namespaces that allowed, it's not the case of Freename, but others do this, that allows the creation of top-level domains that are exactly the same as generic top-level domains or even country code top-level domains. And then we have also collision in between Web3 namespace themselves. It's not a secret that, for example, in Handshake and Unstoppable, the .wallet top-level domain has many collisions between domains. The fact that we have unregulated namespaces proposes different challenge. So how we solve or how we assess first these challenges and then provide a solution to the users so that they may use in a secure way, in an intentional way, proper resolution of domains. First, we have to find a way to prevent collision to occur, meaning that if we are a namespace, we may put forward some rules, a priori rules, saying that, for example, we will not allow the creation or the usage of top-level domains that are ICANN top-level domains, for example. And we have to provide also a simple way to make the user understand these rules. But we also have to make everything safer. So, as I said previously, Web3 namespaces may have the same challenges that the ICANN namespace has. For instance, Web3 namespaces are also prone to IDN homoglyph attacks, record spoofing, creating domains that have similar names to protected trademarks or very famous brands. This means that the system must put in place similar solution as in the ICANN namespace. For example, we may use clean DNS to receive signals and guard against phishing, multi-op redirects, and different issues that we see in the ICANN namespace. Also, we have to ensure some kind of coexistence, not only between Web 2 and Web 3, but also in between Web 3 namespaces. So what we actually do in Freename, and I want to tell you this because I'm responsible for this part, we have a pipeline of research and development. And what we did in the last 2 years in Freename was, first of all, to gather data, to understand what happened on different blockchain and in different namespaces. This means scan, gather, and index as much information as we can from blockchains. The advantage of blockchains is that they act as an historical record. I said in the introduction that a blockchain provides immutable information. That means that if I want to change something, I can only add another information saying that the previous information is not more valid or something has changed. But this gives us a lot of historical data that maybe in the ICANN namespace is not available if I think that now I can scan the icon namespace starting from the root zone files and then go and index all the domains that we have, we get the situation right now. Then I can backup this kind of snapshot and keep it in a time series. On the contrary, on a blockchain, it is possible to see the past. And the past gives a lot of information of the evolution of domains and also of records that may be stored on blockchain. Doing this realizes some kind of very complex database with a lot of information that we can then use to perform analysis, also comparing to the conventional namespace, the icon namespace, and we can we can create metrics. We can create trends. We can see KPIs or compute or post-process information. So we devised what we call the Noto protocol, which its aim wants to be the formalization of a real protocol that can be publicly used by namespaces to achieve consistency and make Web3 domains trustable and make them pointing to the right information with security. The protocol is a rules and score based protocol. It means that rules which may be conditional or other kind of rules will yield some kind of score when we ask for the resolution of a given domain. What that means practically is that, for example, dude.satoshi, I may ask to Noto to resolve to a wallet address these domains. And if in the indexing database, I already found the very same domain in other namespaces and so on, a set of rules will determine which one should get the highest score and therefore be the one that is resolved by the resolution system. So, for example, the fact that a domain may exist before the very same domain created on another chain will yield a higher score because we want to provide precedence to the age of a domain. But we can also choose how many records a domain has. For example, a domain that has 20 records may be considered more important or should take precedence to the very same domain with less records on another namespace, and therefore will get a nice higher score. By resolving the domain, we should provide the one that has the greatest number of records, for example. These are just examples of how the protocol can first be configured and then can provide a resolution for Web3 domain names. This is a schematics of the system where we can see different layer of data. Of course, to index, analyze, and then be able to execute all the process that yields scoring of domains, we have to put in place some kind of infrastructure that must be performant and should answer as fast as we expect a DNS server answer a DNS query. In that case, the protocol provides resolution through APIs that may be integrated. And then maybe at the end, we may also discuss the fact that we can use also private DNS server, for instance, to provide some kind of resolution. Of course, these private DNS servers should be segregated from public resolvers, but it is not a secret that in a DNS server, we may define a zone that has a Web3 domain and not only a Web2 domain. So by creating the set of rules that may be configured and to provide resolution, we have different categories of tools and concepts that have been put in place. So as I said before, we have an execution phase of the algorithm that scores a domain, but then we can superpose other rules, other conditional criteria to override the behavior of previous rules, or we can also define authority levels. If I deem that a given Web3 namespace, let's say Freename, which I know that I will not have TLD collision between ICANN TLDs and Web3 TLDs, I may say, okay, domains defined in a given namespace automatically may have been given some kind of authority, and therefore resolution should be prioritized on this namespace. We also have other rules that come in place in this protocol, which are not different on how we act in the classical namespace. So we may also decide to block queries or to redirect. We may actually make a domain invisible, meaning that it's still visible on the blockchain, but by refusing to resolve some of all records, we make it unusable. This is actually what happened in the ICANN namespace. You have a domain, you receive a signal of abuse, for example, or a trademark complaint. There is all a process of assessment and so on that are put in place. And then what a registrar does is like park or suspend or block the domain. But what actually we do in practice, as you may know, is to make the domain unusable. And to make the domain unusable, we have to erase or lock any kind of resolution. We erase name servers, or we change the name server so that a user is no more in control of the DNS zone. And practically on Web3 namespace, we do exactly the same as we do in the ICANN namespace. I want to show a practical example, which is more industry related or more for technical people, of what is the output of this resolution system put in place by the Noto protocol. I spoke about APIs. For example, the protocol provides REST API with their own resolver, and we can resolve Web3 domains. This resolver, the Freename resolver, supports also other namespaces. Why? Because we indexed many namespaces, and we actually use the scoring system to give priority to a given resolution. Here you see an example where you may notice the fact that we provide anyway records similar to DNS records, because we may very well mirror DNS records on blockchains, but we also have all the data and metadata concerning the actual NFT that represents the domain itself. So you may see the blockchain where it is defined, the token ID, which means the NFT ID, and very important, the owner address. Being a Web3 namespace, we also leverage the capabilities of the blockchain itself. I was speaking about smart contracts in the introduction, smart contracts being kinda programs that may be executed and whose output validated by different nodes. And we provide the resolution also directly on chain. This means that in that case, the smart contract becomes like an oracle, a source data provider for resolution that stems out from the blockchain itself. You may see, for example, the function of our smart contract that can be, some of them can be publicly invoked, meaning that a partner or somebody that wants to provide intentional resolution of Web3 domains may hook to these functions and execute this function directly on chain. We spoke about resolution, and we saw one of the first challenge that we have in Web3 namespaces. For instance, we were talking about collisions, but as I already anticipated, we have other challenges, or let's say harms, that are similar to what we may find in the ICANN namespace. Of course, Web3 domains are subject to phishing, doxing, any kind of financial fraud. We hear every day about frauds that happen in the Web3 world. The Web3 community talks a lot about this. There are a lot of discussion, and people start to understand the gravity and the risk by manipulating domains that are not mapped or resolved in a meaningful way. We have also domain spoofing. We may, for example, let's think of the fact that we may change the resolution of a domain by changing a wallet address. This means that I believe that I am sending money to you through a wallet. In reality, I'm sending the money to another person. We also face the fact that since everybody can create or mint an NFT representing a domain on a blockchain, we have to ensure the originality of the Web3 domain. So we must be sure that it comes and was validated and controlled by an entity that formalizes the way it wants to resolve domains. And we saw, for example, that the Noto protocol is one possible solution to do this. In the Web3 world, harms are also very dangerous, and security is hard to enforce. Why? Because we have anonymity. It's very difficult to track persons or people behind wallet address, behind smart contracts, and so on. It seems like a contradiction. Blockchain are transparent, but are also anonymous. And that's why sometimes blockchains are used to perform criminal actions or to simply put in place a system that has no accountability and where everybody can do whatever they want. On top of that, the fact that the infrastructure is decentralized, when we want to act, we want to investigate, we want to find the problem of a given abuse, we have to go everywhere and check everywhere where this happens. So in the ICANN namespace, in a way, you receive a signal, there is a protocol that tells you what to do, and it is unique for everybody, every registrar in the world. In our case, it's difficult. Also when there is a criminal intent behind those arms. But anyway, blockchain is transparent enough to provide evidence, meaning that being a public ledger and being immutable, what we see on chain may be used for forensic analysis, may be used to obtain information that is true and validated. For example, simple blockchain metadata, a token ID, we can see if the token has been minted by a given address, where it moved during its life, and so on. And we can also see what we call wallet flows. For example, how many times the domain changed ownership. We may try to understand with indexing and analytics if behind many wallet address there is the same person or the same agent that hacks in a malicious way. And all this gives us a way to provide reports, to provide evidence collection for forensic analysis and incident resolution. So what we want, so first of all, I want to ask if maybe it's somebody has questions, because I know we went on some deep and technical concepts. If at this stage there are no questions, I may continue. I don't know, Lars, how you want to, if you want to have a clarification stage.
Thank you, Paulo. We actually already have one question in the questions part, and I would have saved this for the end, but we can discuss this now to motivate people to get engaged with further questions. So the question that we have is from Nicolas Flumarelli, and the question is about the trade-off between performance and security. And also, and in this context, his main question is about quantum resistance technology. So, how future-proof is the blockchain technology that you and other providers are using in terms of being future-proof, and how are those systems are able to evolve and change cipher algorithms?
Okay, I think I've understood the question, but let me take it from an introductory point of view. We see, so we have a technology which is the blockchain. This technology shows transparently a given information. This information is immutable thanks to cryptographic process that have validated this information. And that means that what is stored there, it is a fact. It is what we see. Then the protocol is something that we build on top of that. And of course, it lacks the decentralized nature of the blockchain itself. But this is what we want. We want a system that gives us a set of tools to take decision, for example, for resolution, or to take decision to say, okay, this is a malicious behavior. We have to do everything to avoid any harm to somebody. And as I said previously, we may enforce this centrally by, for example, telling everybody providing some kind of resolution, please stop resolving this, or erase all information that may be used to perform harmful actions. For the future, so technologies are evolving, but the principle doesn't change. It means that we will always have to implement a set of rules whose outcome is some kind of probability or score that can tell us, okay, this domain may be used to resolve, and the information that I got from this blockchain is the one that actually is the one that to be prioritized. I don't know if this is the answer to the question, because it was maybe more generic. But the trade-off is this. So we have a decentralized world where everybody can, in principle, do whatever they want, but we try to offer centralized services to help the users achieve a meaningful usage of the domains defined on blockchains. I think you are muted.
Thank you. If there's a follow-up question, we have a few other questions in the queue. So, Nicholas, if you want to respond to this, please feel to do so. But there's another question from Nicholas, and this is about if there's an equivalent to DNSSEC on the blockchain. You discussed token IDs, but he would like to learn more about authorized entities.
So authenticity of the information is not something that is implicitly defined through a blockchain. As I said, anybody can write whatever they want. The fact that namespaces have been born is actually to provide some kind of centralized structure of information, or let's say metadata, that can be attached to an NFT on the blockchain, and this metadata will be absolutely mutable. And this is a way to provide authenticity of the information. The fact that an NFT, a domain, has been minted by a smart contract, that the smart contract is known to belong to an official namespace through, for example, an ID, is sufficient and necessary to provide authenticity. It is different as the DNS works, whereby we leverage DNSSEC to ensure the client that the information that will be retrieved comes from an authenticated source. So there is not really a mapping of the concept of DNSSEC between DNS, the classical namespace, and blockchains.
Okay, thank you. But this is a good segue to the next question that we have from Sandosh from Afnik. Is it possible to have a blockchain domain like toto.ens resolved to DNS web and vice versa, a domain name toto.fr resolved to Web3?
I didn't understand. Can you repeat, Lars?
Is it possible to have a blockchain domain like toto.ens, as an
Yeah.
example, resolved to DNS web, so I can DNS, and vice versa, a domain name like toto.fr resolved to Web3?
Oh, yeah, of course. I mean, first of all, for example, Ethereum name system is a good example. So this resides on the Ethereum blockchain. Of course, we cannot. We can, as I said previously, you can very well put in place your private DNS server, define the zones that you want, create a community that connects to this authoritative DNS server, and therefore you may obtain resolution of a Web3 domain through a DNS server. And of course, you may use it to resolve. And once a DNS server provides this information, we know very well that a browser use the result of this resolution, for example, to point to a website. It is indeed possible. What you have to do, of course, is to ensure that, for example, the SSL certificate of the Web3 domain pointing to this website supports the Web3 domain, or else you would have, for example, a security warning from the browser. Conversely, this is interesting. Yes, we may very well use ICANN domains like a .fr or a .com to define what we call Web3 records. These are not classical records, so they will not be A records, CNAME, TST records, but you may use an ICANN domain to point a wallet address. This is what actually the Noto protocol and Freename does. We can, for example, we say mirror an ICANN domain, a .com domain, for example, put the NFT on chain, of course. The existence of the NFT doesn't change the usability and all the context that the ICANN domain has. Is just a proof of existence on blockchain of some kind of information. But then we can define what we call Web3 records. And if you have paolo.com or lars.com, you can put it in MetaMask and send money to lars.com instead of a wallet address. This is indeed possible with the resolution. Different namespaces provide this resolution. We do it universally, meaning that you can really define any kind of Web3 records through the Noto protocol.
Thank you, Paolo. We've got another very good question from Carsten Schiefner, and he would like to know if Web3 domains are actually GDPR compliant, because as you explained, all information about the history of the domain name is stored in the blockchain, and so he's addressing the question if this is GDPR compliant, that also maybe personal information is stored in this way.
I would say that by default they are compliant to cure, absolutely, for the reason we said, because of the anonymity. Of course, namespaces avoid to put some kind of personal or private information on chains. Normally, data of customers or registrants, as we call them registrants also in Web3 namespaces, is indeed a secret of the namespace himself. So what you see on chain is in general not private information. Of course, you may have malleolous agents or namespaces that through errors, they make errors and so on, and by mistake, they store some private information on chain, which would make it actually public. And but this is a process error, and the GDPR actually defines mitigation, defines fencing, tells how we should proceed. First, to avoid that this happen, and second, if an accident happen, we have a procedure. As for any digital company, we should have a procedure to face this. So announce, track the information that has been exposed, and provide a solution. Of course, data that is on chain, as we said, cannot be changed. So the only mitigation, if indeed an error like this happen, is to somehow detach this information from the namespace, actually by burning the domain, so burning the NFT. It means sending the NFT to an owner address that has no actual physical owners. It's like the null address. This is a way to show that the information should be discarded officially on chain, but indeed, if there is some kind of string written, some kind of a set of bytes written on chain, it will still be visible.
Thank you very much, Paolo. So we've reached the top of the hour. Paolo, I know because I know your slide deck that there are a few more examples left, but I think that would be a perfect segue to address maybe other issues in a follow-up webinar. So, or if you would like to summarize them very quickly, because we've reached the top of the hour.
Yeah, I know. No, I wanted just, it was almost the conclusion, so I wanted just to talk about the collision management engine and go in some details of the algorithm actually, and make an example on how also the protocol may handle IDN homoglyph attacks and so on, by showing that we can put in place rules that detects IDN homoglyph attacks, and therefore we can recognize trademark abuse, for example, which is something that, of course, happen also in the classical namespace. One of the last slides wanted to be um, I wanted just to show that we can define any kind of domain. In general, emojis are supported also for Web3 domains. I know that there are registrars that allows this also in the icon namespace, but just wanted to laugh about the variety and the fantasy that people put in creating domains. Actually, in Freename, we have people very interested in top-level domains with emoji or in domains with emoji. They personalize an identity, which is actually maybe the purpose of a domain name. So what is the purpose of a domain is to identify something to univocally and be also beautiful and pleasant for the person holding it, to be proud, to give to other people and say, hey, you can send money to this or with my domain, or you can reach my website with this Web3 domain. So that was in a way how I wanted to close the discussion.
Thank you very much, Paolo. So thank you very much for taking us on this wonderful journey through Web3 domain names. I think there is still potential to have follow-up webinars on this to dive more into substance. But I think it was already a general introduction that was very helpful. And also thank you for addressing the issues and hurdles that this journey um, uh, brings along. But thank you very much to be very transparent on this. I would like to thank all the participants who joined us today, and looking forward to welcome you to our next edition of the Best Practice Webinar series again. As I already mentioned, you have the opportunity to provide feedback as soon as the room will be closed in every minute. I would like to thank you again for your participation or for your interesting questions. And with this, I would like to close the session and wish you a wonderful rest of the day. Thank you very much.